This is a key to the worksheet on topic 23, part D, worksheet 1. Now, when completing this worksheet, it's very important that you use the factor theorem and the remainder theorem to a certain extent. But the factor theorem is what you're going to be using mostly on this worksheet. So the factor theorem says this: if you have a polynomial and it has this factor, x minus c, so if x minus c is a factor, notice that the factor is linear and the coefficient of x is 1. Okay? So if you have this factor, then that you see the c right here? Again, x, it has to be x, not 2x, not 2/3 x, but x, coefficient is 1. Then f of c is going to be 0. So the remainder, remember the same thing as the remainder theorem, so that remainder is going to be 0. So 0 is this remainder. So according to the remainder theorem, this is your remainder. Okay? So see, same thing here. F of c, your factor is x minus c. I've got to be a little bit careful. If the remainder is 0, then the factor is x minus c. All right? But if the remainder is not 0, remember one of the previous lessons, then x minus c is not a factor. All right? But if the factor is x minus c, so if x minus c is a factor, when you do that synthetic division, I can use synthetic division here because this is linear and the coefficient of x is 1, then the remainder will have to be 0. Okay? All right, so let's see how we can use that idea in number 1. So look at number 1. So number 1, you're told that f of 3 is 0. Okay? So that means that when x is 3, my y value is 0. What is a factor of this polynomial function? Now, you're not told what that polynomial function is, and it doesn't matter because all I want to know is what is a factor of this polynomial function. I don't care how many factors this has, what is one of them? And you're going to use this information. Well, according to the factor theorem, if f of c is equal to 0, see that if and only if, then I can go backwards as well. If f of c is equal to 0, then a factor has to be x minus c. So you see right here? So f of 3 is equal to 0, so c is 3 here. So then a factor, according to the factor theorem, one of the factors has to be x minus 3. And so that's your answer. So one of them is x minus 3. Same thing with number 2, right? So if you are told that g of negative 4 is equal to 0, and you want to find a factor of this polynomial function. Now again, we are assuming these are polynomial functions, all right? So a factor of the polynomial function, according to the factor theorem, if f of c is equal to 0, then a factor has to be x minus c. So a factor has to be, now I'm going to write it like this for right now. You're going to say x minus a negative 4. But you're going to say your answer, though, is x plus 4. So make sure you say x plus 4. Okay, so a factor has to be x plus 4. Okay, now look at number 3. So number 3 is written differently than numbers 1 and 2. So number 3 and 4 are written differently than 1 and 2. Now, when you read number 3, it says this: if 7 is a 0 of h of x. Now, what that means is this. This means that h of 7 has to equal 0. That's what that means. So when x is 7, then y is 0. So 7 is a 0 of h of x means that when x is 7, my y value is 0. Okay? That's what that means. The y value is 0. So now this looks like this. So if h of 7 is equal to 0, then according to the factor theorem, then that means that x minus 7 has to be a factor. All right, has to be a factor of h of x. All right, so the answer is x minus 7. And the same thing here, if negative 6 is a 0 of n of x, then what would be one factor of that polynomial function? Well, if negative 6 is a 0, this means that n of negative 6 is equal to 0. And according to the factor theorem, if n of c is equal to 0, then n minus a negative 6 is a factor. But you're going to write the answer as n plus 6. All right, the answer is going to be n plus 6. Okay? All right, so that's numbers 1 through 4. All right, let's look at number 5. Number 5. Okay. All right, in number 5, you are told that f of x is 3x squared minus x minus 2. And you're told that f of 1 is equal to 0. All right, so right away I know I can use the factor theorem. And so I want to use the factor theorem to help me to factor this. Now it's a quadratic, so it's easily factorable, but I want you to use the factor theorem with this. So we know this. We know that according to the factor theorem, x minus 1 is a factor. All right, so we know this. So we know one of my factors is x minus 1. I just got to find the other factor. All right, now here's the way we're going to do this. We're going to use synthetic division. So remember, this is a remainder, right? All right, so that remainder is going to be 0. So if I use synthetic division, so this one goes here, and so I get the coefficients of my function are 3, negative 1, negative 2, and it's in descending order, and there are no missing zeros. So I get 3, bring down to 3, multiply, you get 3, add, you get 2, multiply, you get 2, add, you get 0. So this has to be 0 because that's what you were told, right? So remember this quotient, if that's 0, if the remainder is 0, then this quotient is a factor. And remember how to get those variables. So this is x squared, this is x, and that's your constant. So another factor is 3x plus 2. And so now remember, the direction says factor f of x. So don't write this and say you're done, because you got to answer the question. So you need a factor f of x. So you found the two factors, x minus 1 and 3x plus 2. So your answer will be f of x will equal x minus 1 times 3x plus 2. So there's your answer. So you factored f of x into two factors. Okay? And notice that to get these two factors, I used what you were supposed to use, which was the factor theorem. So if f of 1 is equal to 0, then one of your factors is x minus 1. Then I use synthetic division to find my quotient. So if f of 1 is equal to 0, then I better get 0 here. And so now here's another factor. So another factor will be this quotient. All right? So this quotient right here, so this quotient is another factor. All right, so that's number 5. Okay, so let's look at number 6 now. So number 6. So number 6, you want to factor g of x. Now that's not as easy as the previous one. So you really have to actually do some work and think about what you know. Well, this is what you're given. You're given that g of 4 is equal to 0, correct? All right, so here's your work. So if g of 4 is equal to 0, then according to the factor theorem, x minus 4 is a factor. So I know one of my factors. So one of my factors is x minus 4. All right, but I got to find the others, correct? So then how do I do that? Well, I'm going to use what we already know, using the remainder theorem and the factor theorem. So if g of 4 is equal to 0, then we know x minus 4 is a factor. So if I take this and divide by x minus 4, I will have a quotient. And I can look at the quotient to help me to factor the remainder of this. All right, so listen carefully. So you're going to say 4. So you see g of 4, so 4, and then the coefficients. So using synthetic division. There are no missing terms, so I'm going to have 2, negative 13, 17, and 12. Now according to this, though, I better get a 0 here, right? The remainder better be 0. And then my quotient, I'll be able to factor. Okay, now listen to what we're going to do. So we're going to use synthetic division, bring down the 2, multiply, you get 8, add, you get negative 5, multiply, 4 times negative 5 is negative 20, add 17 and negative 20 is negative 3. Multiply 4 times negative 3 is negative 12. Add, you get 0. I was supposed to get 0. Okay? So that's that remainder. So now this right here are the coefficients of my quotient. So this is x cubed, then this has to be x squared, and this has to be x, and that's your constant. So my quotient is 2x squared minus 5x minus 3. Sometimes some textbooks will call this, when this quotient, the depressed polynomial. Sometimes they'll call it that. So if you see that word, that's what that is. So when you do that synthetic division, then this is your depressed polynomial. That quotient is your depressed polynomial. Okay, now, so here's what we know. I just want you to think about this, okay? So listen carefully. So right now I know this. I know g of x. Oh, and by the way, so since my remainder is 0, then this is another factor. So then 2x squared minus 5x minus 3 is another factor. All right, well, what does that mean? Well, that means this. That means g of x is equal to this factor times this factor. So it's equal to x minus 4 times 2x squared minus 5x minus 3. Okay? So g of x, which is this, is equal to this times this. All right, but remember when you did factoring, you have to make sure you factor completely. You have to factor completely. So if you look at this trinomial right here, I can factor that further. I can factor this trinomial further. So you got to do that. So g of x is equal to x minus 4 times, and I can factor this as 2x plus 1 times x minus 3. So you see this right here? That's this. So 2x times x is 2x squared. A positive 1 times a negative 3 is a negative 3. The outer is a negative 6x. The inner is 1x, and you get negative 5x. So this is your answer, and this is your work. All right, so that's how you use the factor theorem and the remainder theorem. All right. Okay, let's look at number 7. So in number 7, we have this polynomial function, and this time you're told f of negative 2 is equal to 0. So you want to use synthetic division to help you find the other factors. Okay, so here's your work. So since f of negative 2 is equal to 0, by the factor theorem, this means that x plus 2 is a factor. All right, so I know one of my factors. All right, and so to find the other factors, I'm going to use synthetic division. So since f of negative 2 is equal to 0, then if I use synthetic division, put negative 2 here, and then the coefficients of my polynomial, there are no missing terms, and it's already in descending order. I got 1, negative 2, negative 5, 6. Now, remember, since f of negative 2 is equal to 0, that means I better get 0 right here, right? Okay, because that's the remainder. That's the remainder. According to the remainder theorem, 0 is the remainder. So here's 1, 2, negative 2 times 1 is negative 2. Add, negative 2 is negative 4. Multiply, negative 2 times negative 4 is 8. Add, negative 5 and 8 is 3. Multiply, negative 2 times 3 is a negative 6, and you get 0. So that's what we're supposed to get. So my depressed polynomial, your quotient, sometimes they'll call it a depressed polynomial, will be, now remember this is x cubed, right? So this has to be x squared. And remember in the previous lesson, you know why that's x squared. Because you're taking this and dividing it by this, and that's an x. So x cubed divided by x is x squared. So that's x squared, then it has to be x, and there's your constant. All right, so my quotient or my depressed polynomial, so some textbooks will use that word, polynomial. So your quotient is x squared minus 4x plus 3. All right. So here's what that means. So that means that since the remainder is 0, all right, since the remainder is 0, this quotient is a factor. So this means x squared minus 4x plus 3 is a factor also, since the remainder is 0. So f of x, which was equal to x cubed minus 2x squared minus 5x plus 6, that original problem, I can factor it like this so far. Here's one of my factors, so it'll be x plus 2, and here's the other, x squared minus 4x plus 3. But don't leave it like this, because if you can factor this further, you want to do this. And so this can be factored further. So f of x will equal x plus 2 times, and then over here I can factor this as x minus 3, x minus 1. And there's your answer. Okay? So there's the answer. So that's the process you go through to find the other factors, and then use that to factor your function f of x. Okay? All right, so so remember the process. You're given this right here, so since that's equal to 0, then x plus 2 has to be a factor. Then use synthetic division to find the quotient, and then you factor, this is your quotient right here, and then you factor the quotient, and you factored f of x. Those are your three factors, x plus 2, x minus 3, x minus 1. Okay, so that is the key to this worksheet.